Yeah, we have quorum now, Scott, if you want to get started.
Sure. Great. Mike, did you want to say that again, or do you want me to just continue on?
I was I was going to suggest that if anyone wanted to say anything about the side news about Dan, the other Dan, they might want to do so. It's not someone I knew particularly, so I know that a number of people here did. So I don't know who wants to lead out.
Yeah, why don't I yeah, so I can say something here. So I don't know how many people knew Dan Williams. He was the chair of our kernel SIG. He was a longtime Linux kernel maintainer. I got to know Dan through our work at Intel, and even before we really worked together, our paths had crossed for other reasons at the company. And one of them was because he was just a very welcoming individual. He was very patient with people. And I think there is a stereotype of a grumpy old Linux maintainer and uh, maybe a personality that is not very tolerant or welcoming of new people or people that don't understand something or don't agree with you. And Dan Williams was the opposite of that. Um, he was very patient with everybody who would come into the Linux kernel SIG or just in general with technical topics, non-technical topics. Um, his family was also really important to him. One of the first things I learned about him were uh, anecdotes that he shared about his family. So it was sort of telling to me about how he prioritized his own thinking. And I know that his own family is uh, going through an unimaginably difficult time right now. There is a link that circulated on the mail list for people who are in a position to help them out. So I'll put that link into the chat in a little bit here. One of the ways that I was thinking about that we could all just kind of take some time to remember him, or even if you didn't know him, that would be fitting with his impact on those around him, is if we all just took the next minute here to think about an interaction that we have coming up, maybe with somebody in this community, maybe with just people in our personal lives, and kind of think about how we can pause in that interaction and be patient and welcoming with them, and think about what kind of impact that might leave on the other person so that they can pass that along to the next people that they encounter.
Okay. Thanks, Dan.
I'll also add that this was announced to the broader Linux Foundation community as well, and there are plans in the works to host a sort of remembrance of Dan at an upcoming LF event. So when I get more details, I will share that with this group as well.
And if I may just add that in a predominantly male-dominated community, we must remember that mental health is a problem that does affect young men disproportionately, and that we should look out for each other. And there are opportunities for men and women, of course, to step up and just ask how people are. And we should do what we can and be aware. It's not always obvious. It's not always easy. but we want to be a welcoming, friendly, and supportive community in all ways we can. So I've been affected by this in other parts of my life, and I'm aware that this is it's a very difficult thing. So thank you to everyone in this community who is supportive and helpful, and long may that continue. Thank you.
Thanks, Mike. Okay. Hello, everyone. I'm Scott Rayner from Intel. If you don't know me, welcome to the August 6, 2026 meeting of the CCC TAC. Just a reminder, this is a community-focused organization. Everyone's welcome with constructive discussion. Feel free to chat on our projects, our meetings, our papers, etc. Just a reminder about our antitrust policy of the Linux Foundation. A lot of us here are competitors, but we're all here for the same reason. So we have a pretty good agenda today. We're going to go do the normal welcome, some old business announcements. We have a few topics to talk about, including Trustworthy Identity SIG update from Mark, Tech Talk by Nathaniel. There's an agentic AI paper that has been put out there and got some great discussion so far. There'll be an update on the TAC white paper by Alec, and then we'll just chat a little bit about the blueprints. I'm not sure Simon's going to make it today. I got a bounce from his email. The next meeting on August 20th in 2 weeks will be chaired by Ahmed. We'll talk about the certifier framework and the framework for continuous attestation from MITRE. And again, we'll talk about the blueprints A and B if there's more discussion there. We don't have any voting today that I know of, so I don't think we need to take any roles. We do have quite a few representatives here that I can see, which is great. This is the time, if you've not been here before, maybe even twice, you could please let us know who you are, where you're from, what's your interest in confidential computing. That would be great. Is anyone new to this audience? It looks like I recognize pretty much all the names here, so that's great. So the old business from last week, we talked about the Auckland project and the fact that it's going to be entering emeritus status soon. We talked about the fact about the agentic AI paper that at that point in time was blank, and it is not now. We'll talk about that a little later. Maybe look at it briefly. And again, the normal continued work on the A and B blueprints and the TAC white paper that Alec is going to talk about. So as I mentioned just a moment ago about the MITRE, there is an attestation paper out there, and they're asking for feedback. I think it was posted on the TAC Slack channel. Please have a look, give any feedback that you might have to that. It'd be great. So the new business, as I mentioned, we're going to talk about the trustworthy workload. Nathaniel's going to give a tech talk. And then the other white papers and blueprints we'll talk about briefly as well. So, Mark, the trustworthy workload identity update.
Yes, if I may share my screen, we can proceed.
Absolutely.
All right.
Absolutely.
Oh, let me do that. So, hello, everyone. I'm sure all of you know me by now, so we'll skip the introduction. I just came back from IATF 126. I attended several working group meetings and side meetings, so I will include some of that in what I'm going to discuss. Again, you know I'm opinionated. I will try to call out instances where it's my personal opinion versus what I consider fact. Also, I welcome all challenges to all facts and opinions expressed. So I believe we have enough time that you can interrupt with questions. So just raise your hand. And with that, again, I just want to make sure I have my Zoom meeting in focus, so at least I see. Yeah, there we go. Okay. So busy season for Workload Identity Group, and so I'm excited to report a lot of things that are going to follow. So we're first going to talk about the recent progress. And so turns out, and you can actually see this when visiting IETF, these halls do not have a lot of customers. Lots of people, engineers. Elon Musk says engineers' biggest problem is, some optimizing or inventing a thing that shouldn't exist, and also like lack of customer insight. I believe does pose certain blind spots, and I'm having been on both sides of this particular fence, I'm hopeful to be providing these. So there are some old festering problems that need rectification, and constant vigilance is needed to prevent new problems, and I will highlight instances of both. And towards the end of this talk, I will talk about code talks and documents, not as strong as code. So I will be talking about what needs to be developed to show some of these, the possibilities ahead of us. All right, so I will talk specifically about contributions that the TWICE-SIG has made to 3 different IETF working groups and an organization that's outside of IETF. And so let's go through them one by one. So first one is WIMSI, Workload Identity in Multi-System Environments. We have a very good working relationship with them now. And so an old version of the WIMSI's architecture, which is still not an RFC, but it's a pretty advanced draft. But it used to commingle the credential acquisition and credential usage, and it introduced things like agent. And the reason is because I believe WIMSI was co-developed with SPIFFE. And because confidential computing just wasn't a thing when it was developed, I think an architectural bug crept in. So that needed to be addressed. So for a price of a beer that I bought for Joe Salloway in Seattle, I convinced him that it would be really good to just do one thing in the architecture, just separate the fact that credentials are acquired or the stage where credentials are acquired from the stage where credentials are used. And the moment you start mixing them, turns out all sorts of difficulties creep in. So if you read the latest WIMSI architecture draft, I will email this deck so you'll be able to click on all these links. You will see there is a special section that very carefully words the fact that WIMSI really focuses on credential usage, not on credential procurement. But there's a little bit of leftover logic that basically says, well, for instance, you could be acquiring credentials this way, but it no longer dictates that it does that way. So that's actually a big win. But like communism, bad ideas creep in and need to be swatted down once in a while. So 2 drafts were presented at or submitted to the WIMSI working group that I again link here that you're free to look at later. And both of them would effectively insert evidence and such into the WIMSI credentials. And that has all sorts of problems. So I personally believe that both drafts are dead on arrival, and I believe that the WIMSI working group chairs agree with me. But this is where continued vigilance is required to make sure that people don't accidentally standardize something that makes our life difficult or impossible. All right, so the group outside of IETF, SPIFFE Inspire, as I said, they're very closely related to WIMSI, and I observed some time ago that the SPIFFE Inspire architectures are fundamentally incompatible with confidential computing, and that is because of this thing, the manner in which workloads procure credentials under SPIFFE, and the problem there, of course, is there is this workload API, and you can see the proto thing here, the message that's parameter. Let's just say, give me my certificate. And if you look at the message that's response, is here's your plain text certificate, but also here's your plain text key. So there is no way to specify nonce. There is no way to reply to the nonce with evidence. There is no way to receive attestation results. There's like none of it is there. So it's not possible for workload to and the node is trusted, the agent is trusted, all sorts of problems. So anyway, so Usama, real quick, so we can also do a much longer discussion at the end.
Yeah, very quick question on the last slide. So you were mentioning about this draft on Whimsy workload attestation.
Yeah.
And I wanted to ask, like, can you maybe give a 1-minute summary of why do you think this is, if you go back, I don't know what the term you used, like bad or something like that.
Well,
I think these people, I know these people, they are also working with confidential computing.
Yeah.
And at least I don't understand why you call it bad. I also attended Whimsy meetings.
Let's circle back to that. I mean, if we have time at the end, I can pull up the draft and we can sort of go through it line by line. But ultimately, the second you commingle credential procurement with credential usage in the same protocol, again, it becomes a product, but it doesn't become a deployable product. And that's my opinion. So, and also, I'm happy, more than happy to discuss this in a twice SIG meeting. Just, connect next time we're discussing that. So I filed an issue in SPIFFE GitHub. Issue 395, again, linked below, that basically says, look, guys, you need to work with us to make sure that confidential workloads can also operate in the SPIFFE Spire universe. The response generally has been, why don't you propose how you seek to have it done? I'm working with them right now to at least offer some architectural guidance. Because you know how it is. You have a project, you have an architecture, some bozo comes in and says, well, change your things this way. It's much easier to get guidance first and, play with a few ideas and then come in with a pull request. So that's in progress. The RATS working group. And this is why the twice-SIG exists, is because in the RATS RFC, I believe there was a naming error. Okay, and again, this is personal opinion. In RATS, this thing is called the relying party, and judging by how RATS architecture is implemented, lots and lots of people assumed that the relying party is effectively your SQL server, your MongoDB server, your whatever existing relying party that now needs to understand attestation results and the appraisal policy for attestation results, and it becomes like a new authentication mechanism, which is a hard deployment blocker. So we introduced this concept of a RATS unaware relying parties, which are RUPs, and the thesis is there are both impossible in the RATS architecture because they are RATS unaware, sort of by definition, but they're also inevitable in the real world. We published the document, which is in our working group folders. It's called The Impossibility of RUPs in the RATS Architecture. It basically explains all of this. And for IETF 126, we published an IETF informational draft called Trustworthy Enrollment of Secure Credentials. If you read it, you'll see it's a little bit rushed, but we needed to get something out. We did not get a hearing at 26. It's just they basically said we're only looking at accepted work and work that's already in progress. They didn't have 2 meetings. There was no real overflow, but because of so many other efforts underway, there will be an interim RATS meeting in September. We're hoping to get a hearing there, and I will talk shortly about the sort of the significantly updated version that we're hoping to update this draft and submit it. Again, we have about a month. I think it's in early September. All right. So finally, there's this. This is where I'm going to get highly, highly opinionated. Okay. So there's the SEAT, which is extensions for attestation. And the observation I made that I stand behind, and I link all the evidence here, is that both the use cases for SEAT and the architecture of SEAT are fatally flawed, like very, very flawed. Specifically in that, if you follow them, you are going to have both resiliency issues and governance issues. So you will basically develop something. And again, I'm using very, very strong language here.
Mark,
but
yeah, sorry, it might just be worth reminding people or explain to people who don't necessarily know exactly what seat is in this context, just in case
Yeah,
not
so it's a
everyone
seat working. So basically, these are attestation extensions to TLS ultimately. So it's a way to modify the TLS protocol to insert evidence into the TLS exchange. Right. So again, I link all the documents here, but it's basically if I have a client and server and they want to attest to each other, it's a way to modify the TLS handshake to provide evidence and receive responses and whatnot. So I sent an email to the seed working group that you're welcome to read again, where I basically say, look, at the very least, please do the following. Update your use cases and architecture to highlight the need for, so specifically for the use cases, you want to make sure that your verifier is not in your critical path. So it's the same as, and again, I reference the if you have to invoke a service every time in order to perform a TLS exchange, and that service goes down, your entire enterprise goes down. That's like unacceptable, and we've had engineering failures like this even in the ITF community in the past. And the second one is you absolutely must separate for regulatory reasons, not technical reasons. You need to separate trust anchors for evidence about platforms and whatnot from the trust anchor for identity. Yes, Osama.
Yeah, hello. So I was one of the editors of the use cases draft, and before adoption, it is now an adopted draft of the seat working group, and now there is one editor. Basically, you're calling it both flawed in the sense that it failed to recognize and blah blah blah. So the problem is that actually, like as editors, one has to recognize that the working group was very new, and whatever use case was brought to us, we pulled it up without like nitpicking too much. That's the I'm telling you
Sure.
the real thing, right? So there was no huge barrier that we put that, okay, so this crosses that bar, now put it in. And that's one reason I want to highlight that it's not specifically from the editor side. We had a very few contributions. The working group was really new, and it's not been even a year that the working group has been formed and so on.
Right.
And there are very few people from the confidential community, computing community, who are actually in the IETF, and it's
Yeah.
actually a call for action for you people to come there and have your use
Yeah.
cases brought up. Like it's if
Well,
nobody raises a use case, then of course like that will not pop up suddenly in the use cases draft.
so the good news after ITF is that Nathaniel Ritz, who's the chair of that working group, is now joining the TWICE meetings, and we're having a productive relationship. So again, I'm not meeting this to be confrontational. I'm
So
just basically stating.
Nathaniel is not the chair of the seat working group.
Okay, well, forgive my mistake, but at least he's working with us. But anyway, so let's move forward. So again, very, very much personal opinion. I don't think seed needs to exist. I believe, and again, it's falsifiable. I'm very much can be convinced. Otherwise, I do not want to argue this here. But I do believe that if we were to procure credentials based on remote attestation, again, separating credential acquisition from credential usage, then we do not need to change the MTLS protocol. We don't need to reanalyze anything. We don't need to take on the, again, protocols are hard. Changing them is dangerous. I feel deeply uncomfortable, doing anything that's not absolutely necessary in this regard, and I do not believe it's necessary. Again, personal opinion. We can litigate it in other forums. So in that work group, I'm other than basically telling them, make sure that you design something resilient and something that can pass regulatory scrutiny. I'm, I do not have the bandwidth to work on something that I do not currently believe needs to be there in the first place. All right. So another big realization over the last several months in the TWICE was that in the enterprise, vast majority of workloads are replicas, right? We define replicas as workloads that are functionally indistinguishable from the point of view of their clients and servers. So you actually don't know which of your horizontally scaling, EC2 instances you're connecting to, other than you're connecting to the one that's going to perform that same identical function. And because of that, we also believe, and especially with confidential computing and data and use protection, that it's perfectly fine to have these workload instances share the same credentials down to the signing keys. And the good thing is if you don't have to mint new credentials for every time your workload comes up, then you also reduce the load on identity providers. And also it's better for resiliency, because if you have an intermittent outage of an identity provider, you are not going to have such a widespread impact on your enterprise, your uptime. So we published this document called the TRI Profile for Replicable Workloads. In there are swim lane diagrams and a very detailed threat model, which, again, as a protocol person, I fully expect there will be bugs and everything, so feel free to critique. Now let's talk about what we're going for right now. This is hot off the press. This has not even been presented in the TRI-SIG, only in very rough details, so you're kind of first to hear this. But what we're working on right now is on this thing called the TRI Unified Model. So let's go through some requirements for what a unified model means. It's effectively making workloads work with whatever is out there without having to specifically tailor them to your credential acquisition mechanism. Right? So if you want to use X59, if you want to use JOTS, if you want to use WITS, just say what you want, and providing some way of doing this such that no matter if you're using any of the existing credential acquisition mechanisms, you'll be able to do that. So I believe now that it is possible. Now it needs to be proven with code, and let's talk about that. So we want to support minting new as well as retrieving pre-provisioned keys. So we want to support workloads that require new credentials, as well as replica workloads that are perfectly happy sharing keys or credentials with their peers. We want to support everything under the sun, X59, WITS, JOTS, pre-shared keys, whatever comes up in the future. There must be only a minimal trust boundary expansion of the workload implementation. So for instance, I don't want to pull the entire agent into every workload for Spire, because for one, that increases your trust boundary. It also increases the code size and all sorts of other things. So we want minimal trust boundary expansion. Basically provably minimal, like you not get away with less than that. It needs to work with at least EST, which is RFC 7030. That's a way of acquiring certificates or other credentials over HTTP, and Spire. And whatever comes up in the future, would like to be able to future-proof it as well. It needs to work with background check and RATs and passport modes. So you shouldn't actually care from the workload perspective which it is. And you cannot assume, you cannot in Nitro, for instance, that your workload has independent network or storage access. You cannot just go say, well, contact my verifier and do something for me. You basically, you only talk to your hosting environment in this case. So it's a pretty severe set of restrictions. So let me show you how we now believe it can be done. I see messages in the chat. I'm happy to go through them. I'm not far from the end of my presentation, so just please hold on. If you want to speak up, I'm not reading your chats. Just raise your hand. So there is an architecture, and there is a couple of profiles that I'm going to show you. So, and by the way, for the interim meeting in September, we would like a POC, ideally based on Verizon. May still be possible with 4 or 5 weeks remaining. We'll see if we can have enough resources lined up for that. But this is a hint of what I think we'll be presenting at the interim meeting in September. So we have this document. Everything I'm showing is going to be in this Google Doc, which is, again, very early draft. It's getting improved literally by the day. So let me go show you through the sort of the proposed architecture for this TRI unified model. So you have a workload, it's a trust boundary, and the only thing we're adding to it is a client for a credential acquisition API that I call CAPI. That's it. That's all you add. There is a certain API that allows you to say, okay, we're going to talk to this credential acquisition system. It could be on the same machine, different machine, multi-machines, but there's a CAPI server that basically answers to our request. So you can do maybe discovery. You can say, well, you gave me a nonce, and now let me give you some evidence. and whatnot. So that's the protobuf for that is being defined right now. But and I'll show you what it looks like in the next slide. And it's the credential acquisition system that talks to the identity provider, to the RATS verifier, to some key or credential store, whatever it may be. The workload doesn't need to know or care. So there is a couple of different profiles here. On the left, you see the EST, and on the right, you see Spire. And just visually, before you go into details, look how similar they look. They are, other than the EST client on the left speaks the EST protocol, and on the right, it's effectively the Spire agent and the Spire server. Right? I should actually rename Spire client into Spire agent. Right, so there is no big difference, but in some cases, the ST server is hosted by the certificate authority, and again, there is open source for that. Or maybe ST server took some sort of key credential store to retrieve credentials. Right, same with Spire. It could be giving you newly minted creds from the Spire server, or it could be giving you some stored creds. And it's the job of your server, EST or Spire, to actually talk to the verifier. And everything here is outside the trust boundary of the workload. So it's effectively what I call a dump pipe. So again, this is an early proposal, hoping to put some code underneath it. Finally, what are we going to do with the ATF going forward? So the first one, the twice specific stuff, we want to update our draft that we've submitted to ATF already with the details from this unified model that I just showed you. I would like to present it at the interim meeting in September, ideally with some code to accompany it. There is this other effort that I believe needs to. There is a bunch of. For one, location of a workload is a absolutely very, very serious regulatory concern. And what happens right now is we have a cottage industry of solutions for geolocation. There is quantum position verification. There are like some things that say, well, we have a GPS sensor. Oh, we're just going to use the TPM, and TPM will tell us, or whatever it is. But they're all trying to go develop their own standards. But we have this other effort, that's the multi-attester. So you have compound device, that basically has CPU, GPU, smart NIC, whatever, attesting as a unit. And then you have multiple attester verifiers on the other end that basically handle all this evidence. The idea is to take all the best ideas of the existing drafts in geolocation space, shove it under one framework where you're just, location is just a form of evidence that could be given to you by the CPU, or it could be given to you by some sort of a QPV card, or it could be a GPS sensor attached to the machine, or whatever it is, and specify one way of expressing evidence claims and evidence collection, represent location in evidence, represent location in attestation results, down the line, maybe even standardize some policy languages for converting one into the other, like evidence into attestation results. And hopefully by IETF 127, we'll have a draft, and I signed up to co-author this with a couple of RATS principles. Okay. So finally, one other thing, and this is, look, there's lots of discussions on agentic identity. My experience has been, if people don't consider confidential computing as part of any new effort, confidential computing ends up incompatible for whatever reason. So we need to, as a consortium, actually not just TWICE, but as a consortium, we need to figure out what these efforts are, where they are not supporting confidential computing, and engage.
Okay, so
right.
Mark, can
Yeah.
I address this particular point?
Yeah.
So there is, a couple of things. Firstly, the GB agreed in June that one of the CCC's strategic pillars should be agentic AI. So this is a good thing. Also, I can note that there are there are Linux Foundation projects, one called the AAIF, which is called of all things AI, and also Manny points out agentic computing, not just agentic AI. I do apologize. And also there's a thing called itself the agentic naming system or service or something similar, both of which I think are relevant. And number of people have said, yes, we should definitely get involved, but there's been no movement. So if people do want to get involved, I can absolutely put people in touch to do that. But we do need to get a bunch of people who are willing to stand up and say, look, our company wants to do this. Whether that's premium members or smaller members, I really honestly don't care. But I would love to see this actually happening. And I think it's something that we do need to do. But we need names to people who are going to make it happen. Preferably some big companies, and premier companies are the obvious way to do that.
Yeah. Right. So again, I can say that on behalf of my employer here, we are also interested in figuring this out, and there is a wide range of opinions here, right? So I simply want to note that there are certain implications to identity. Right. So, I would I'm happy to work with anyone on this area. So let's just move past this. This is not something I'm prepared to cover in any depth. All right. So this is my final slide. So what am I asking of you guys? Yes, Osama.
Yeah, so on the topic of agentic AI, I want to add one more thing. So in the IETF, like there were 5 BOFs this IETF meeting, and none of them succeeded. So, and there were quite a few side meetings, like there is a real hype around AI and agents and so on. But the real thing, I think, which is missing technically, not from marketing perspective, from that technical perspective, I think the real thing is missing. What is AI compared to a normal workload, to a normal software,
Yeah,
piece of
and even
software,
on that, there is a
and
range
so
of
on.
opinions. Even on
Right.
that, there is
Yeah,
a range of opinions. Like if you ask me,
sure.
an
Yeah,
AI agent is just another workload, right?
right.
What I would like to understand is, and again, I'm not prepared to drill into this topic right now. Okay, so
Yeah,
we
sure.
may,
Sure.
but
My idea
we
was
need to
just
have
to,
agreement on requirements. Like what's different? What is sufficiently different that we need to secure differently? So I'll give you an example from a related domain. We know how to build reliable systems out of unreliable components. This is why we have RAID. This is why we have the various ways of doing stochastic engineering, and we have geo-redundancy and whatnot. But when you take a look at the LLM failure modes, the difference is between AI and non-AI is not in degree, but in kind. There are different failure modes. And you are not going to solve the problem by the same tricks that you've honed over the last several decades, right? So we need to figure out, is the difference between the AI agent and a regular deterministic workload, is the difference in degree or is it a difference in kind, right? And only then, when you understand the differences, can you actually go and, try and propose solutions. Right now, I don't even have that clearly defined anywhere.
sure. I mean,
So, but we need to move on because I'm not prepared to talk about AI agentic identity here. I'm just telling you what the starting point may be. Dan.
Yeah, so we've got the agentic paper coming up a little bit later in the agenda, so that might be a good thing to hang around for if you can, though I know your time is
Yeah,
limited.
I have to drop at the top of the hour today, unfortunately.
Okay.
All right.
The other question that I had, though, was what is the position that you're taking to Spiffy Spire community? So they have like a very lax definition of attestation by cryptographic standards.
Yes.
And I'm curious if you're getting confidential computing attestation, if that's like the main thing that you're promoting.
So when we developed this CAPI that I referred to before, I believe I can take CAPI and insert it into the Spire Workload API as an extension. So the Spire Workload API, it's just a protobuf, just a file, and actually link it to in the deck. You can open it and read it, right? And it's completely open to extensibility. So if I could basically say, here, your workload API, here is a proof of concept, here's some code, and it actually works for confidential computing. And if your workload implements it, then it can go and do all the things, right? Right now, the workload API supports X509, it supports JOTs, and it supports WITs. Right? I can basically say it can support all of the same, but such that you can actually do remote attestation from inside the workload. Right? Again, I very much welcome developers and architects to actually work with us on this, which this slide is all about. So please attend our meetings. We've had maybe 4 or 5 people tops in our meetings. And unfortunately, nobody from Google, nobody from Microsoft, nobody from hyperscalers. And that is not serving anyone. Like it's not going to help us if we have to do this in isolation. I believe the ideas are solid. What, you know, the success of any technology is measured by its adoption. So great ideas will die if not somebody doesn't pick them up. So we need help with prototyping, developing our content, the various documents, reviewing of this content and whatever code we prototype, and also IETF contributions, also IETF attendance. Like I went to Vienna, but looking at the schedule for the next 3 IETFs, I am likely not going to be there in person for the next few. So that concludes my presentation, and I'm happy to take questions. I will email this deck to the TAC.
Thank you, Mark.
And while I have your attention, I emailed the TAC now multiple times asking for some of our pull requests to get approved, and I'm getting very annoyed that nobody is responding or doing anything about it.
Do you want to do that right now?
No, I don't want you to approve my pull requests now, but please refer to the email I sent to the TAC pointing at exactly the things that we need review and approval on. And in fact, maybe I could use a point of contact who I can, so I don't have to email the entire TAC, basically saying, look, we have a new thing that we need to get into the GitHub. Will you please take a look or find the right people to get it into the hub? Because right now I've emailed you guys since May. I have not received anything. It's been 2 months, 3 months.
Yeah, that's not good. So other TAC members, we don't have a lot of traffic on the governance repo. I know it's easy to have GitHub notifications filtered on purpose or by accident.
Yeah.
Just periodically, maybe when you're thinking about preparing for this meeting, just go to the governance repo and double check if there's PRs. We never have a lot of PRs. It should not be a lot of time for people. So please try to spend 5 minutes.
I just like at some point in time, I tire of being a nag, but like we need some movement. It's been clogged. Anyway, questions? Osama.
Yeah, just a quick comment. Since you mentioned seats, so I have a new draft which covers the trust problems of the protocol related design that we need to have. So I will put it in the chat. You can have a look. I also sent the email in the mailing list. And these are quite high severity attacks that one should be care of. The architecture should be designed in a sense
Osama,
that the protocol supports that.
I understand that like about half of your communications are about relay and replay attacks. And I'm telling you that first, before I personally get interested in this, you need to convince me that any of this needs to exist. Okay. I'm very much of the opinion that if you procure credentials first based on remote attestation, and then you can use unmodified TLS protocol with that. So I personally the reason I'm not involved in these discussions is because I personally do not believe any of this should exist in the first place. Right? I do not know how more clear I can be. But at the same time, if you're going to propose an architecture and implementation, make sure it's you can make it highly available and governable, right? And then I could be very wrong. Maybe it needs to exist and it will exist. Again, adoption is the key success metric. So I'm happy to be proven wrong, whatever. Like it's not a religious statement. But if somebody needs to convince me, for me to look at it, that procuring credentials first and using them later is not as for some reason misses something that's super important to an enterprise.
I mean, how can I convince you with something more than a CV of 7.5 and some CV which are like now under like responsible disclosure 9.1, 3 CVs of 9.1, 1 CV of 9.8. Like what else will convince you? Maybe if you can help me, maybe in the chat or maybe later on or on the list, it would be very nice for me to understand like what exactly can I do like CVs are not created just for formal models. They are for real working code. And there is a real attack which is demonstrated and approved by the developers and accepted by them. I don't know of any
If
other
I
way I can
perform,
help you?
if I perform remote attestation and I now have a credential that's tied to a workload based on remote attestation, and then I use that in TLS to authenticate effectively my client or server, I do not see how that can be subject to an attack.
So that's we proved that
But
like
if
2 years
insert
ago. I will
evidence
put it in the
into your
chat.
hand, if you insert your evidence into the handshake, that means you modified your TLS client or your TLS server. And from that point on, I'm not interested. I do not want modified TLS clients or servers.
So we don't modify. We are not saying do it within that. So that's also dangerous. What we are saying is do after that. So that's our proposal. That's what I'm saying.
Okay, great. Thank you, Mark.
Yeah.
I won't project to show just the one slide, but we have a tech talk by Nathaniel on layered file systems and the confidential compute trust problem.
Thanks, Scott. Hopefully everyone can see this.
Yes.
Okay, so my first note really here is to apologize to all of you, because I've actually snuck a business talk into a tech talk. So my sincere apologies to everyone. This is a talk about increasing demand. And I think, the security, privacy, and integrity guarantee that we are already advertising in confidential computing is strong. So this is, however, a talk about making people want it. So we've handled the supply side, and I'm worried about solving the demand side. And so fundamentally, in my mind, this looks like a marginal cost problem. That is, what is the difference between the cost of a confidential workload versus the cost of a non-confidential workload? And whenever that cost is above zero, the cost of adopting that is a cost that everyone is going to have to bear. And so basically, unless there's some security policy or some regulator that dictates it, people will choose not to adopt it. However, when that marginal cost becomes zero, or at least approaching zero, this question inverts, which is when there is no cost to adopt it, why would I ever do anything else? And so, in terms of increasing demand, I think the simplest, most direct approach for this is simply to reduce our marginal cost to as close to zero as possible. And so for any workload, there's essentially three cost centers. The first one is the one that everyone sort of thinks about, which is the runtime cost center. This is, your footprint, it's your boot latency, it's your density of how much you can scale them, it's your IO tax, et cetera, et cetera. So that's the one we tend to think about a lot, particularly as many of us come from hardware manufacturers. We tend to think about this one a lot. But actually, I would argue that the larger cost is actually the lifecycle cost. And that lifecycle cost is the cost to build, ship, store, update, rollback, et cetera, a workload at scale. And there are two notable costs within this, which are collaboration, which is what it costs for multiple parties to contribute to one artifact, and specialization, which is whether each contributor can stay within their own competence. We'll discuss both of those more in a little bit. And then the third cost one is generally what we think of as security. I'm calling it exposure in this sense, which is that when the cost goes up, we have increased exposure. Mark, you have a question already?
Yeah, so I would just add the key, a very, very key adoption blocker while we're at it, may also fit under lifecycle. If in order to update, so most data is exchanged between pairs of workloads, right? Like the humans actually transact very, very little with computing systems. So if I update a workload and a workload has clients or servers, and you need to make one line of change to your client or your server for confidential computing, you just shrunk your target market by 95%.
Sure.
Okay, that's all. That's my comment.
Yep. Okay, so moving on from these three cost centers, the market's already historically made this trade two times. We started off with bare metal, where our runtime costs were very high, mostly due to stranded capacity. That is, we'd have one application per server, it would sit idle most of the time, and therefore we had the capacity, but we couldn't utilize it, and that drove very high runtime costs. Lifecycle cost was also extremely high because in order for us to manage any application, we essentially had to do physical asset management as well as all of the software deployment. Exposure was generally low, however, because we could physically isolate things between servers, and often, most of the time, it was on-prem and usually managed by the department that was deploying it. But obviously, the industry has moved dramatically away from bare metal and towards traditional VMs, at least historically. And this provided a runtime cost that was lower. It also provided a lifecycle cost that was still somewhat high. You still had to basically build what was effectively a server image and then distribute that. But both of those costs decreased relative to bare metal, and the exposure cost went up, is the important thing. So what they did was they traded the cost of exposure for lower and runtime cost. Of course, none of us want to hear that. We're all security engineers here, but this is the reality of what the market chooses. The next transition was an important one, and that was the transition to containers. This introduced likewise a lower runtime cost, but actually its biggest advantage was not in the traditional VMs. It was actually in the lifecycle costs. And we'll talk a little bit about why that is the case. But I think it's important to highlight a trend here, which is that two times in two major transitions, the industry has traded exposure, that is increased risk and decreased security, for runtime and lifecycle savings. And so this means that we have a comparison problem in the confidential computing space, which is that we market ourselves as privacy added oftentimes to a VM. And this is a coherent argument, but it picks the wrong baseline. Basically, the market is leaving traditional VMs because they want the lower cost of those containers. And the cost of VMs is only going up. I'm not sure if you've heard, but the price of a certain vendor doing for their VM instance has gone up dramatically in the industry, and lots of people are moving around trying to find a lower cost alternative. The important thing here is that if we're trying to say, oh, look, we can add privacy to this technology that people are trying to stop buying, we don't actually have a comparable, right? Because what we have to deliver to the market is a marginal cost against the thing which they actually want. And so this has been recognized, I think, many times inside confidential computing as a whole, oftentimes by proposing that we confidentialize the container. And this, there's lots of implementations of this. That they generally follow the model of let's run a container inside a VM, and therefore we can make the unit of distribution a container, but we'll just ship it in a confidential VM when we deploy it. And it works mostly until you look at the bill. When you look at the bill, you have your VM runtime cost and your VM lifecycle cost, plus all of the container lifecycle machinery, plus all of the additional costs that have been added. So you basically just added the cost of the VM to the cost of the container. And so this is not going to compete successfully against a container because the costs are just simply too high, and it has an unclear value proposition. So the key here is that the VM is the wrong comparable. Well, the comparable is the container. And so if we're not talking about a runtime, lifecycle, and exposure cost that competes with a container, then we're probably comparing against the wrong thing. So the runtime cost, I think, is mostly a solved problem. It is can be handled by building confidential micro VMs. The industry isn't super mature here yet, but it's a fairly straightforward path. And we know how to build micro VMs. We've been doing this with, Firecracker and a variety of others for quite some time. But no one has really touched the life cycle cost part, and that's the part that I want to focus on today. So the important thing is that the life cycle part has really been one of the key deciding factors in both of the prior transitions. And so what I'd like to go through here is what containers got right. So part of it was runtime cost. It's the smaller half. There's no second kernel, shared page cache, milliseconds to start. All of these things are great. We can do most of these things with a micro VM as well. So it's not like this is not something that's achievable. But the larger savings here really is in the lifecycle layer. And the mechanism for that in a container is the layered image. Fundamentally, layering is a social technology. It allows for both collaboration and specialization, which I had mentioned before. It allows for different parties to participate in the compilation of a workload. So you can have an OS vendor, which provides a minimal patch base. You have a runtime provider, an application owner, a model provider, a data owner. All of these parties need to be participants in the creation of a workload, but they need some official mechanism to do so. They need some way to collaborate. And this is the thing that drives that lifecycle cost down and was a key invention of containers. So in contrast to this, VM images are mostly antisocial. So where a container image can compose at deploy time, you get all these different layers, you pull them together, no problem. With QCOW or really any other monolithic VM image, it's a monolith, and the party that builds the monolith basically has to be an expert in everything. So that you can't do specialization because you only have one party that can build every single part of the image. And so, yeah, VM images basically are antisocial here. But we have a bigger problem with OverlayFS. And this OverlayFS, for those that don't know, is how containers actually create their layered file systems. OverlayFS is a file system overlay where you basically say, here's a file system, and then I'll layer a file system on top of that, and so forth, and you layer them all up. And that's what creates your layered image distribution. So for OverlayFS, when we want to think about how we might deploy something like that in confidential computing, we see that there's a significant problem with the trust model. Mark had already mentioned, right? If you don't design something for confidential computing, it ends up getting sort of broken along the way. So here, the host is going to download all the layers. The host verifies all the layers have not been modified. The host assembles all of those layers, and then the container just consumes the assembled virtual file system on faith because it trusts the host. Of course, the problem here is in a confidential computing, we don't trust the host. The host is actually inside of the threat model. And so this is precisely the entity that we want to remove from the TCB. And so OverlayFS really can't work in this context, and it's why everyone basically ends up shipping containers inside a VM. So what we fundamentally need to do then is we need to fundamentally divide these roles. So, and we need to then verify the integrity continuously. So first, we still want the host to download. The host being downloaded and being a content distribution network, that's great. That's exactly what we want. Clouds are already really good at doing this, so we don't want to change this. However, we want the guest to be the party that actually verifies the layers and assembles them into a single coherent view. And basically, we want to have a threat model where we don't have to worry about the host manipulating anything. Further, verification is not an event, unlike with an OverlayFS layer. When you download an OverlayFS layer, you want to verify that the CDN didn't modify it because the host is trusted. But in our case, we want to continue to store the data on the host, but we want to verify that the host is actually giving us back that correct data. And so I want to walk through what it might look like for us to design a solution to this problem and provide the same sort of layered distribution and building of images that we have seen in the container space, but we want to be able to do it for a VM. And so we fundamentally need to shift from doing this as at the file system level to doing this at a block device level. And the really good news here is that the Linux has a series of tools called the device mapper, and this actually has all of the Lego blocks that we already need. And so the important thing here is everything I'm about to say can be implemented entirely without any kernel modifications on stock kernels today. So we're going to be using 3 specific device mapper targets in order to achieve this. We're going to use DM0. DM0 is a virtual block device. The virtual block device, all it does is read zeros and discard writes. You can think of it as the dev null of block devices. So what you do when you create this virtual device is you simply say, I want a block device of size n, and it creates this virtual block device for you with n number of blocks. And every time you read a block, you get a 0, and every time you write a block, nothing happens. So that's our core primitive. Our next one is DM snapshot. And DM snapshot was created precisely to handle the copy on write snapshotting, similar to what QCOW does. And basically what it does is it creates a virtual block device by utilizing 2 other block devices. So the first one is the origin. So that's the one that doesn't have any changes. And then it has a copy on write device. And so when you create a DM snapshot block device, what happens is when you try to read a block, if the block has not been modified, it will be come from the origin device. So that's your read-only lower layer. On the other hand, if the block has been modified, it will instead read that from the cow device. And but this is presented as just a single merge. So you don't know that this is happening. It's totally transparent to user space. And basically, when you write a block, all writes go into the copy on write device. And so the copy on write device basically contains the blocks that have been modified plus an exception list. The exception list basically says, these are the blocks that I have here in my copy on write device. And so what happens when you instantiate this then is that the kernel loads the exception list from the snapshot, and it basically just handles the routing to whichever device is underneath it. And so this basically gives us our layering. This is essentially overlay FS semantics, but it's one layer down. It's not a file system, but rather we're going to be layering based upon 4K blocks that are beneath that file system. The last tool that we want to use is DM Verity. And DM Verity is another virtual block device. And what it does is it also has an origin underneath it. And then it has, rather than a cow device, it has a Merkle tree device. And so this has a Merkle tree which guarantees the integrity of all of the blocks that are underneath it. So when you create the virtual device is going to, you say, give me block number 17. And the kernel is going to go load block number 17. It's going to load it from the origin device, but then it's also going to simultaneously calculate the Merkle tree, for which a bunch of it is cached in the kernel to make it fast. And the end result is that any modifications to the unreliable storage that's underneath the DM Verity will be caught and surfaced as a runtime error during the operation. So these are the building blocks that we're going to use. And the whole of this Carapace invention is basically this line. What we're going to do is we're going to combine the DM snapshot and the DM Verity. And so what we're going to do is we're going to have the copy on write layer is actually going to be a DM Verity protected cow device. So that you see data there on the right-hand side, that's the actual cow image. We're going to wrap that in a DM Verity, so that gives us our integrity protection for each individual layer. And then we're going to wrap that in a snapshot. And the snapshot is going to have the origin, which is the layer below, and the copy on write is going to be the DM Verity. And so in a normal deployment of DM snapshot, the copy on write half is usually mutable. But in this case, because we're putting it under DM Verity, it now becomes immutable. This means that the DM snapshot we have created can never be written to. It is always a frozen verified delta of blocks between between its layer and the layer below it. And the important thing is that because we are pointing the origin to the layer below, this can stack with all of the other layers. Now, we can do this pretty straightforwardly, but the astute listener is going to highlight a problem here, which is that, okay, well, we can do this. We can layer essentially this DM snapshot and this DM Verity. But if we do this, now we have to manage a hash that is going to occur at every layer. That hash is going to tell us what the integrity of that particular layer is, and we'd have to have one per layer. Well, that's not very manageable. So we're going to have some way to communicate all of these hashes to a guest so that part of the guest measurement, say, or an out of band delivery to the guest can do that validation. But we don't want to have to, like, if we've got 30 layers, we don't want to give 30 separate hashes to the guest. It's not going to fit on the kernel command line, and it's not efficient to manage. So we want to solve this problem. We could like just concatenate them all into one big long hash, but that's not really a good solution. And so what we really want here is we want to have one hash that covers the entirety of the chain of all of the layers. And so how do we actually do that? Well, we can do that through something I'm calling salt chaining. And basically, the way that this works is that each layer has a salt. So this is part of DM Verity today, and the purpose of DM Verity for it to have a salt is to basically make the root hash look independent for every image. So this is if you wanted some privacy on your image of some kind where you could have the hash be different for every single one, you can put some salt in. Well, instead, what we're going to do is we're going to use that to contain the next layer's hash. This does two things. First, it gives us a place to actually store the next layer's hash in the existing file format. So that's convenient. But the second thing that it does is that it actually mixes the prior layer's hash into the Merkle tree that is produced for the upper layer. And so this means that if the host were to try to change the salt value, for example, then all layers above it would fail to validate. And so with only the top level hash, you get cryptographic validation of the entire tree, and we've reduced the layering hash problem now to just a single hash. Now, a single hash is very easy to communicate and distribute. People are already doing this with DM Verity and confidential computing today, and we can reuse all of those same mechanisms. But now we get layered distribution. So we don't have to have a manifest for this. We don't need a signature. We don't need indexes or in any new formats. We just simply store the hash in the next layer up salt, which is a field that already exists. How do we terminate this chain? So this is what a full chain might look like. By the way, we call layers scoots, and carapace, for those that don't know, is like a layered armored shell on an armadillo, and each individual plate in that is called a scoot. So we have a set of layers. These are scoots 0, 1, and 2, and each one chains to the next one down. The floor of this is that DM0 device that I was talking about. And so basically in the carapace spec, we define that the floor always has a constant size. This is very large. I think it's like 32 exabytes. So it doesn't matter that it's very large because DM0 is a virtual device anyway, and it's always going to return 0. So it doesn't change the size of memory allocation or anything. But then each layer above it uses DM0 as the floor. And because DM0 is guaranteed by the guest to contain zeros, we don't need integrity protection there. So we can chain all of these up to the top. So we have DM0 on the bottom. We also use a 0 salt as a prefix in the base layer. And this allows us to easily and efficiently determine when we've reached the end of the chain. So it's essentially a sentinel that marks the end of the chain. And that allows us to compose together an entire chain of layers. So as I mentioned before, because of this, one hash can be used to identify the entire chain of layers. And but we can also use this hash for discovery. And here I'm just borrowing what DM Verity already does with systemd, which is that when you want to mount a DM Verity partition, you just simply pass the hash on the kernel command line. that root hash is divided into two, and it becomes the partition UUID for each of the sub partitions in a GPT partition table. So essentially, with that root, with the root hash, you can use the root hash to find the partitions that are the top level scoot. Then you can look at the salt to get the next root hash. Then you use that root hash to find the next layer and so forth. The point is, from exactly one hash, we can perform discovery of all of the layers, and we can compose the entire thing in the guest. And importantly, all of discovery can be untrusted data because everything is validated cryptographically from that one single root hash. Once we have that hash, and once that hash is either measured as part of the boot or validated in some other way, once you have that hash, the entirety of your layered file system becomes trusted. There's another cool hack that we can do with this, which is that we can actually ship half of the scoot. And so what do I mean by this is we said that for each layer, you're going to have a data volume and you're going to have a hash volume. Well, the interesting thing is that because the hash volume is deterministic based upon the salt that's produced, you don't actually have to even distribute that volume. So when you want to actually distribute your particular layer, that one layer, you can discard the integrity Merkle tree altogether. And the only thing that you need to distribute is the data volume itself and the parameters that go into DM Verity. The parameters are just a few dozen bytes and can be included as metadata in whatever your distribution mechanism is. And so the only thing that you have to ship, again, is the data volume itself and a few dozen DM Verity parameters. Now, how does this work? When you want to download this and you want to run it, you can download each layer. And as you are downloading it, you can actually calculate the DM Verity partition in the download because you've already got those bytes in memory. Just do it one block at a time. Produce the Merkle tree as part of the download, and bada bing, bada boom. At the end, you've got both the data volume itself and you've calculated the DM Verity hash volume. Now, doesn't that mean that I can manipulate it? No, it does not. Because if you remember, the hash is contained in the salt, and we're distributing the salt as one of the parameters, and all of that is measured, and again goes back to the root hash. So the fact that we can calculate this without, it means we can reconstruct it, does not open us up to any sort of modification attack, because the host can only reconstruct the Merkle tree as byte identical from the original one. And so basically, this also means that our poll, it can be fail fast. So if we get a bad layer, we can just abort immediately and we don't have to continue on. I'll skip this slide mostly. Deduplication is a policy choice. So if you go back to this slide, you can see that our salt is calculated from both the root hash and a suffix. The suffix is optional. So if you want to include entropy, you can do so. The cost of doing that means that you can't deduplicate the layers. So all of your layers become cryptographically unique if you put a salt in. But if you exclude the entropy suffix, then all of your layers become identical with identical contents and means that you can deduplicate. So for most systems, they will likely not include the suffix, but for those who, for whatever reason, want that additional privacy, they can do so by adding that suffix. And so what we've actually built here is a social model for VM images. Operating system vendors can publish their base scoots. Runtimes can layer on top of them. Apps, model, and data can layer on top of them. All of your collaboration and specialization costs collapse to exactly the same cost of what they have with a container. When you distribute them, you get deduplication of all of the bits. So, for example, if you have a server that's deployed, 30 different workloads, and those 30 different workloads all use a particular Red Hat version as their base, they're entirely deduplicated. You would only download one copy of that layer. You would also get incremental distribution. So if you want to make changes to the top layer, you don't have to reship the bottom layers. You only ship the modifications you've changed. And then all of the existing benefits for like A/B updates that you can do with containers today, they become possible for VM images as well. Runtime cost is pretty much a non-event. So there is read overhead with DM Verity, and it basically, I've done benchmarking of this. The cost for this at runtime is exactly the same of doing DM Verity on a normal image. So if you have a big monolithic image and you do DM Verity on that versus a broken down layered image, the cost is exactly the same. For DM Snapshot, that has a runtime that's near native. The reason for that is that the kernel loads the exception tables. And so when it's deciding which block to load off of disk, the exception table itself is already in memory and cached. And that doesn't have to be, read or written. It can just make a decision pretty much immediately. So basically above the carapace, you can put a file system. You could put a partition table above it. That's not my particular usage. But the important thing is that you get a real file system on top. So OverlayFS has to have a bunch of workarounds for the fact that OverlayFS is not a real file system, but rather a layered file system. We don't have to do any of those workarounds. So the exact inode, for example, is exactly what it is. On OverlayFS, the inode is a lie. Hard links are hard links on a carapace system, and unlike an OverlayFS. So a rename of a file is exactly the same semantics as renaming a file. The important thing is that everything that is above is basically exactly what you would get with a normal file system. You don't have weird hacks or workarounds. But you do get measurable identity. So you've got 32 bytes for that top level hash, and that 32 bytes guarantees the exact identity of everything that's happening in the guest. And all modification is detected, whether that occurs during the distribution or whether it occurs during runtime. We get a failure at runtime. So the conclusion of this is that essentially Salt's chain produces our layer graph. That's the key invention here. There's no new kernel code. There's no new file formats. There's no new parser in any boot path. There's just simply one trusted value, and everything can work on a stock Linux kernel today. The only thing you really need is just a small setup utility that can actually run this algorithm to set up the kernel primitives, which is a very small amount of code. And so back to our cost equation, this is, I think, the core invention that allows us to solve the lifecycle cost problem for confidential computing, because it allows us to capture all of the lifecycle cost savings that were produced by the container movement. And then we can essentially reproduce those same cost savings using a VM that's running Linux in the guest instead. So here's the opportunity for questions. You can find the specification for this at that particular URL, as well as a simple utility for mounting a file system on top of a carapace that could be used in your boot system. Mark.
You muted, Mark.
Sorry. So yeah, just a quick nugget before I have to drop. I'm not going to challenge anything you said. I think it's fantastic progress, really good ideas. So it's all good. But I think what the TAC should do is explicitly track all significant adoption blockers for confidential computing, because I think it's normal in human nature to say we have this problem and then assume that if the problem is solved, we're free and clear. We're very much not. So I think what was just presented is absolutely a necessary one, but it should be one of several. So I already mentioned, regulators need to ask for it. Another one that's super important that I do not believe your solution addresses, but it's also in the performance domain, is that if you cannot offload your crypto to a smart NIC for storage and network communications, no matter what you do, on the CPU alone is going to get you to acceptable levels of performance, and that is very much a multi-layer problem. You need the protocols, you need the kernel extensions, you need protocol extensions for compound verification, attestation. You need the multi-verifiers, like all of that, and that part, I believe, if we do not prioritize, and now is the time because smart NICs are finally available in the marketplace. Let's track it as the consortium and make sure we make progress on all. Otherwise, it's effectively an end game.
Thanks, Mark.
Mhm.
Any other questions?
Not a question, but just to emphasize what Mark said, if somebody wants to go open an issue on the governance repo and start collecting some of these adoption hurdles, that's probably a really good idea for us to build a backlog of things to address here. I think that's worth everybody's time. Excuse me, everybody's time who's a part of the TAC.
No objection there, Dan, but I mean, we need to get the actual source material for what we see as the adoption barriers. I mean, I heard discussion there, but not something I would be capable of turning into an itemized list that, would make sense to folks, extemporaneously. I mean, someone who just saw this tech talk might make sense of it, but I
Yeah,
sounds like
I'm not suggesting that you go in and create the issue for this particular item. I'm just saying that in general, as each of us has some viewpoint of an adoption hurdle that we're experiencing, we all want to spend our time here working on things that alleviate those problems. So I like Mark's suggestion of we should be cataloging those.
Usama, question?
Yeah, on the point of the specifically like what Dan was saying on the hurdles, of course, as a security enthusiast, for me, the biggest hurdle that is there for confidential computing is the kind of the attacks that are being discovered. And I mean, the whole selling point of confidential computing in the beginning, or since the beginning, has been that, hey, this is by name confidential, right? So if that confidentiality is not, that promise is not satisfied, that's I think that brings us to the point of discussion of why have confidential then not, why pay the price and so on. And I believe Nathaniel was kind of hinting at that at some point in time. So yeah, that would be my suggestion, to keep security as at least one of the factors, even if that's not the most important factor, but that is one of the important factors to be considered for the field to grow and to move forward. Like, I mean, the CVs that I was talking about, and I will put the list of ones that we have in responsible disclosure. When they come out, of course, there will be a there will be a big thing coming out in the news and so on. So I think the community needs to take consideration that yes, speed is important, and like some things like what Mark said and so on. These architectures are very nice to have, like very nice to standardize and all that. But if we keep security as a secondary parameter, or even not secondary, like the third, or I don't know what parameter, then it's not going to fly, I believe.
Yeah, agreed. My focus on costs, up front, was to highlight that there's lots of costs in lots of different areas, and that we need to drive all of those to zero. I've chosen one particular cost here, which is the lifecycle cost, to try to reduce that. But this same process needs to be repeated across all cost centers. Alec.
This might be an unrelated question, Nathaniel, but before we left, Mark said something about smart NICs finally being available on the market. And and this might be wrong, but I think I remember you talking about a new AMD device that is a smart NIC. Is that what Mark was talking about? And if so, do you mind giving us like an overview of what that thing is? I know in Azure we have this proprietary smart NIC that we're trying to use TDISP to bring into confidential computing in the TCP in a responsible way. Is that something that AMD is generalized, or am I completely misreading what I thought I heard Mark say?
You are not misreading it. So all of this was just announced at the Advancing AI event in the last few weeks. And this is the Volcano SmartNIC that is appearing as, right now it's part of the Helios integrated rack solution, but it is available independently as well.
Okay, I've heard of Helios, um, and but I hadn't heard of this Volcano NIC. Does it support TDISP? Is it
It does.
cool? So can you give us a link to where I can read up on this? I'm really because as I've been trying to figure out how to write down a vendor neutral overview of composite Ts that include a GPU and a smart NIC, but all I know is my own infrastructure. I'd love to see another instance of that infrastructure so I can kind of see where there's commonality so I don't accidentally back into a vendor specific paper.
Yep. So I've put a link to Helios in the chat. And I believe that's where you're going to find most of the information.
And it's got volcano specific info and
Yep.
how you guys do attestation and stuff.
It has the announcement. I don't know how much technical details there. Jeremy, are you on the call?
Yes, I am.
Do you want to talk about how the Volcano NIC is doing TDISP at all?
Yeah, I mean it's following the standard, we're compliant with the TDIS standard. We're doing attestation over SPDM. And when we talk about a Helios rack and the overall integrated solution, the expectation would be a CVM would simply bind with multiple devices, like the GPU TDI and the NIC TDI, establish a peer-to-peer connection between the GPU TDI and the NIC TDI, and then they would use that for RDMA or whatever other use cases that they have for the smart NIC. It's kind of like, bread and butter TDISP interactions that you would see here. So, yeah, yeah.
Cool. That sounds good. I don't want to go too deep onto this because I don't know what the rest of the TAC is interested in knowing. I'll read the documentation and get back. I'm really curious to know how much of the attestation evidence that's produced by the NIC is included in something that the relying party eventually sees, and just the nuts and bolts of how reference values are provided, whether the customer, the end user, the relying party has a chance to uh, view the policies that are used to do the evaluations of the attestation evidence versus the reference values, or if that's more like a black box that the CPU decides for itself based on its own policies, whether or not the NIC is trusted.
No, the attestation is entirely up to the CVM and its tenant to decide to verify. The tenant gets its attestation report for the devices that it binds to, which is, this isn't AMD specific. This is TDISP related to. It retrieves the attestation reports over that SPDM channel to those devices. And, as SPDM evolves over time, you're going to see that, mature more. Some devices are providing a SPDM specific format. Some are starting to ship EAT objects across SPDM for their attestation reports. And I think the expectation is that attestation will start flowing towards using like CORM and those kinds of reference materials for verifying, and so AMD's product, like the physical part of it, is not doing any sort of verification of that attestation evidence. It's you can do it in the CVM if the CVM itself is already attested, or you could do it at a remote verifier, like with a whole CVM, all the devices bound to it, and establish trust all at once.
That all sort of made sense. I mean, it actually did make sense. So that was a great explanation, Jeremy. Um, the I guess I'll read through the evidence, but what you just said in your discussion, I think goes beyond any documentation that I've seen about SPDM sort of broadly on the internet. I would love maybe to collaborate with you on kind of generalizing that information and putting it into a white paper that's consumable by our customers. So maybe
Sure.
I'll reach out to you offline. Thanks.
Would it be valuable for the TAC for a presentation on just generally TDISP and how it works with other parts of confidential computing?
It would be
We
for me.
we could certainly do that. I know we've got a talk from, I think, maybe 2 years ago now, from Samuel Ortiz over in the attestation SIG.
Mhm.
So we could have people take a look at that recording and then see if there's something newer that's evolved with the protocol that would be good to get an update on.
Sure.
Yeah,
Yeah.
as I was listening to Jeremy, your explanation, I thought, yeah, of course, this is just all standard SPDM. Why would there be anything specific here? But then I started thinking about having a verifier for the device, and I don't know if is that something that you guys already have provided then?
Part of our product is going to deliver like a reference local verifier that's going to sit inside that you can put inside your guest to verify our devices. But that's not a requirement, right? You can generate your own verifier that sits somewhere else and verifies. Attestation is very flexible in terms of where some of these pieces sit. So if anybody would
Sure,
like,
just that to verify, you need if somebody is going to write their own verifier, that just seems very difficult without understanding the reference manifests that are expected. So,
well, I think, if you look at RATs proper and how all this stuff fits together, there is essentially a generic device agnostic algorithm for determining, given reference measurements, given evidence, does this check out, right?
Mhm.
There are surely device specific bits in the attestation reports that could represent things like, is this device in a debug mode, right? Do we, and how do we reason about the security of the system? And that may require device understanding, right? And from our perspective, we're going to provide some of those policies and documentation to understand how to do that. But to write your own verifier to mechanically go through the CORM objects and the EAT objects and that kind of thing and validate, DICE certificates, that'll all be very standardized and reusable.
Yeah, okay. So you're planning on providing like co-rims and
Yeah.
Yeah.
That's right.
Okay, good enough. Cool.
Alec, you mentioned that Azure has its own implementation. I don't remember if it's called Boost or something like that. So can you talk a little bit about that, and if you could provide the same information that you were asking Jeremy to provide?
Sure, I can say that our smart NIC is called Azure Boost. So
Yes.
that's just the name of our device. We are also working to make it part of, it's going to be a confidential device, and we're trying to do encryption offload to that device and allow, DMA to the memory. So it will also go through TDISP SPDM attestation exchanges. We're doing, I think, what Jeremy called internal attestation as well. So that means that inside of the T, there will be an attester that verifies the evidence that's provided by the smart NIC. And it's the same kind of I think it's going to be the same kind of approach that's being used by ARM in this Helios device. I wasn't sure if what we were doing is vendor specific or if it is going to be a standard that's produced. I know everybody's using TDISP and everybody's using SPDM, but the specifics about how endorsements are handled and how reference values are provided, and then the policies on that are being evaluated by the verification service, all of that is very internal, and I don't know how much. I think it would be good if the CCC weighed in on how much of this internal attestation makes sense and how much it brings the provider of the hardware into the TCB, how much it provides the provider of the whole service into the TCB. When I went through, and I'll just say, my view has been shaped because I've been reading the initial documents that we provided as white papers to the CCC a few years ago, and at that time, everybody was very much in the mindset of SGX and specifically Coffee Lake. And the whole point is we can't trust these cloud service providers. We got to get them out of the TCB, and we've kind of moved a long distance in the other direction where the cloud service providers are providing hardware and they're providing endorsements and they're providing reference values, so that brings them further into the TCB. And I just want for customers to be able to reason about that and understand why what Mark said earlier is, as customers, the performance gains and the cost parity needs that are being driven by the market are forcing us to make hardware devices that meet the performance needs, but then also pull more of the CSB into the TCB. And I think we need to balance that in the CCC to make sure customers understand that we're not making promises. And I think part of the discussion that I've been hearing during Mark and Usama's exchanges is part of the discussion is that people feel like we're making promises that the CSP isn't something that you need to trust, and we need to get that written down in a way that we can all agree on it.
It is definitely the intent of my presentation to move us further down the road of we don't trust the CSP, which is the whole reason why we're validating images on the inside of the guest rather than the outside.
Yeah, I would second that. I think, Alec, I totally agree with what you're saying. There was short-term necessity of, bringing this thing to market and making it work. But the end goal of the CCC should be to, reduce the dependencies on the CSP and minimize the presence in the trust base. So we need to be pragmatic, but the CCC should not just say, okay, it's good enough the way it is now, right? We should strive to remove those trust dependencies as much as we can.
I'm totally with you, Manu, and I'm trying to get to that same goal, but I'd like to see that written down in a way that we can all debate it. And there's great discussion going on, but I'm not seeing white papers that help me understand composite T's yet. And that's as I struggle to try and put my thoughts on paper, I'm not making as much progress as I'd like to. And I think it's for a lack of understanding. So I'll reach out to Jeremy, and maybe you and I can just chat and figure out if we can get a draft together that we, can start to put our principles into plain English that customers will understand.
Cool. Sounds good.
Usama?
Yeah, so from my perspective, I think Alex's questions make a lot of sense. They are very important questions, and it's really important to clarify. But at the same time, I also see that it's not really specific to composite attesters at all. The reason being, and when we are talking about specifically about as Manu explained, like the end goal is fine, but there should not be a collusion between what the end goal is and where we stand today. So having an end goal that we want the cloud providers to be out of the TCB is completely different from making a claim that today or at this point in time, the cloud providers are out of the TCB. And today it is provably falsifiable that the cloud providers are out of the TCB. So I don't think the community should go towards this kind of thing or write such a document which makes it ambiguous or such a thing. Of course, like making trust clear is a nice thing, but I think it should be made really clear what current technologies offer versus what the end goal or the vision or whatever you want to call it. The two things should not be colluded together.
Yeah, getting declared is exactly what I'm trying to do. And as I've been looking through the original white papers, and there's these cool green boxes that show these are the things that are inside of your TCB. And right now, some of the stuff that's inside the green box is provided by CSPs. Sometimes the stuff that's inside the green box is provided by hardware vendors. Sometimes the hardware vendors are independent of the CSP, sometimes they're not. I just kind of want to draw some green boxes and some yellow boxes that show who owns what and whether it's inside the TCB so that customers can understand it and that they don't come away with you know, I'm trying to eliminate ambiguity, Mohammed. That's exactly what I'm trying to do.
Yeah, really appreciate that. That's what I have been trying to convince the tech for quite some time, and I will be really happy to work with you on this as well. The other concerns which I have previously raised, I think have been taken up. The community now realizes that the location is a very critical thing. We have to take location into consideration. And this one is equally important. If we claim or even like make it if we leave it like the way it is in the current technical analysis document, it's really bad that it gives an impression that it is out of the TCP while it is not. Even if I don't talk about any NICs or any GPUs and all that, even with simple VM, simple container, you see that there is no way to provide an identity to that specific container or a virtual machine without the help of the CSP. It's the CSP which will provide that identity. And if that identity is not there, if it's a self-signed certificate, it's going to go to anywhere in the world. We cannot really distinguish these DEEs. And one more thing which is related to this, and I also want to want the tech to consider and to bring to, let's say, more clarity is, and some of the objections I get that is that, hey, look, you are actually like breaking the T by getting the T key out, like the private key out, and then you are claiming that it's broken. It's not like that. The attack that we are highlighting and have been highlighting for quite a few years is that it's not the TEE that you want to connect to. It's not your desired server. It's a server which is anywhere in the world. It's the one that is in your basement or whatever, whichever server you want to take. And breaking that is really easy. Like if all the hardware vendors are saying that the side channels and all these kind of things are out of scope. Out of scope does not mean that nobody can exploit that. Out of scope just means that they are not considering it to be a part of the threat model. And if somebody, let's say I have a server in the basement, I break it with the help of these side channels and then start diverting all of the connections to that specific server. It's that specific attack that we are highlighting, and that's precisely the reason that the severity is too high at that 7.5 level and so on. So that's something I think the tax should take more seriously and think more, let's say, elaboratively into it.
Okay, I think we've drifted well beyond the tech talk at this point.
Yes, Dan, so we're very short on time. Do we want to postpone the agentic paper and then maybe I can pull review in next week or next meeting?
Why don't we spend 5 minutes on it just so that people have
Okay.
it, have the link handy and
Absolutely.
can start looking at some of the comments.
Yeah, I'll put the link in the chat. So here's the link to the actual doc. So coworker of mine, Rego Yaluri, did a huge majority of the work for this. Where is my Zoom window now? There it is. And I see that Manu and Renee in particular have already given quite a bit of feedback. Raghu said he's definitely tried to talk to most of that let me bring it up. There we go, finally. Let me know when you can see that. So really appreciate the feedback there. He's going to some of it, as you probably saw from some of his replies, he'd like to discuss it hopefully in person soon. He had a hard conflict today, so he couldn't make it. Dan, anything to add?
Yeah, just please give it a read through and mark it up where you can add something constructive there.
Absolutely.
I want to add, and it connects to, I read the document and it also connects to earlier discussions today, the whole AI, agentic. I think that it was a deeper discussion about what is this, what's the value of, for example, remote attestation when the code is not, you don't know what the code will be. It's not something that you can trust, like we trust today code that someone assumably can review at one point in time. So I think that the document raises a lot of questions that require a discussion, like was suggested by Mark Novak and other people earlier.
Thanks, over. So yes, please have a read through when you have time. Much appreciated. Let's see. Next on the agenda, the blueprints A and B.
Yeah, let's go ahead and skip that since we don't have Simon
Okay,
anyway.
that's right. Yeah. So TAC white paper update.
There's that mute button. So I've done some work on the paper. Also wanted to thank you guys for your contributions. It took me a little bit longer than I wanted to figure out why I had the wrong version. Turns out both versions were identical. I don't know why that version number changed, Dan. The piece that I kind of want to ask about in just the few minutes we have left, and I'll share my screen. I want to try and merge in. Whoops, I can't share my screen. There we go. Share. I think the feedback I got from you, Dan, last time is it would be good to tie these kind of visualizations of the stack. Let me know when you can see them.
Yes, we can.
All right, cool. I want to tie these visualizations of the stack into my own paper as well, into the overall white paper. There was absolutely no visualizations in that paper, and I wanted to add some to it to help people, visualize the stack as you did here. But I couldn't find the original art for these. Are they in Git someplace where I can see it?
They sure should be, but they're not. Yeah, I'll get the source PowerPoints put in, and I'll send them to you meanwhile so that you've got them.
All right, cool. That would be awesome. If you can do that, then I'll get them incorporated and put them in there. The only substantial change I've made to the paper is to include the attestation as being a hard requirement for the T's, whereas before, whoops, now I've lost my context. I'll just talk you guys through it. Before, attestation was viewed as being optional. for confidential computing. And the idea is you can do confidential computing in secret and nobody needs to know. But as the CCC, we at the last minute decided to make attestation a formal requirement to claim you have a T. That was inconsistently used in the paper. The other big changes I've made is some of the side channel attack vectors that were included at the end of the paper. I have moved them to an appendix so that the paper reads a little bit less long. Hang on, here it is. Yeah, let me just go here really quick and hopefully you guys can see the nature of the changes. So when I ask you to review it, it won't be that big a deal. It's basically just this section here. Whereas before, attestation was viewed, and I apologize for the scoring, whereas before attestation was viewed as an optional additional characteristic that some T's provide, and I really apologize for this for the scrolling now. It is no longer viewed as something that may also be provided. It is now something that is a requirement. It's one of the fundamental T properties. I know there was some discussion about that. If anybody objects, let me know now. If not, the paper that I will suggest that everybody begin reviewing will include this kind of significant change. Any objections?
No, I've got a link to the source. So when we made that 1.3 draft, it went into the TAC repo. So one way to do this would be to make the changes as a PR against that markdown file. Maybe also fine to just put out a Google Doc with it, but we'll want to be able to persist those changes like we did the 1.3 draft.
Yep, that makes perfect sense. And I think the initial discussion was we were going to review it in Google Docs format, and then once we see the changes, add them back as PRs. And I do have a version of this that's in suggest mode. So we can go back to that version and I'll submit the individual changes as PRs to or as a commit to this to the markdown document.
Great.
But I was going to do that after all the comments are kind of closed. Otherwise we're going to have to be dealing with the reviews and it doesn't seem like people do that as willingly as they do in Google Docs.
Fair enough.
Cool. So, all right, Dan, I'll reach out to you on Slack or Teams and ask you to provide me the original artwork so I can add it here. And if there's some changes, I'll make whatever changes and then have are they just plain old Google, what are they called? The PowerPoint equivalent in Google. I can't remember what they're called.
No, it's pure PowerPoint, Alec. You'll have to get a machine capable of running that.
I think I can probably find one of those lying around here, so I'll see what I can do. I can probably spin up a VM or something in one of the public clouds. All right, cool. That's all I got. I'll get to work.
Thanks, Alec. So we're on to the very last. I can't share.
Hang on, I'll turn it off here. Give me one quick second. I've got two windows in my way.
Thank you.
We got like 2 minutes, so
we're on the next meeting slide, so we're done pretty much.
I see Muhammad has his hand up. Sorry, Muhammad. Please go.
Yeah. Very quickly, I just wanted to say a lot of thanks to you. So I think without attestation, confidential computing didn't make any sense at all. So a big thanks to you.
Yeah, sure. I mean, I think this was something that was originally agreed to, and then it just didn't quite make it all the way through the white paper. So I'm just formalizing an agreement that was made, 4 years ago?
Yeah, it's surprising how quickly that went by.
Yeah.
Yep. So just a reminder of the next meeting in 2 weeks, August 20. Ahmed will be the rotating chair. We'll be reviewing the certifier framework. and framework for continuous attestation from MITRE. So that is it for today, unless somebody has anything else they want to discuss.
When's the agenic paper? When's that?
Well, we briefly talked on it a few minutes ago. We just didn't have the time to really dive into it. What I'll try to do is maybe if we have time in the next meeting and he's available, get the author or lead editor Raghu to come in and we can have a discussion on some of these things. He wants to do that anyway, just needs to find the time. Did you have anything specific, Tom, that you want to talk about today?
The question that came up today was whether a workload was an agent.
Yeah, I saw that in the chat.
That is very controversial.
Yeah, we might need to have a dedicated topic on that in the future, Dan.
Sure. Yeah, so we're like Scott mentioned, we'll also try to get Raghu at the next meeting. I'm not sure what his availability is, but that'll be good.
Yep, I'll definitely work on that.
In the meantime, do you want us to leave comments? Yeah, I see Renee's left a bunch of comments in the paper. Yep, I will leave comments in there. I've got it open now. Cool. This is awesome. Thank you.
Excellent.
All right, thanks.
Thanks all.